Hello everyone, welcome to Faangtastic Solutions. So today we'll be going with one medium Leetcode problem, which is about unique paths. And this also looks quite popular questions. This has been asked in almost all good company: Facebook, Apple, Amazon, Google. So everyone is mostly asking these questions. So let's just read the problem and try to come with some solution. So problem says there is a robot on M cross N grid, and the robot is initially located at the top left corner, which is this position 0 comma 0. It says the robot tries to move to the bottom right corner, which is this one, M comma N, M minus 1 N minus 1 position. And it says the robot can only move, so we have few conditions as well. It says robot can only move either down or the right at any point of time. So what do we mean by that? So robot can either move right or down. So that's the one condition. So let's say if in future some point of time a robot is at this position, so now a robot can either go towards the right or down. So these are the valid moves. Let's say if robot tries to go back, top or back, so these are invalid moves for the robot. It says given two integers, return the number of possible unique paths the robot can take to reach the bottom right corner. So we need to let uh, return the total number of valid paths the robot can take from coming from here to here. So the one of the path could be all the way right and then down. So this could be one path. Second would be this one. Third one would be, let's say, this one. And then there could be multiple things, like, so this could be one valid path, right? So we just need to return how many total number of valid ways the robot can reach here. So one of the example, if you look, it says if m equals to 3 and n is equals to 7, then total number path would be 28. And similarly, if m is equals to 3 and equal to 2, then path would be 3. The explanation is given, from top left corner, there are total 3 ways to reach to the bottom corner. Either it says, so we'll just roll this. So either it's right, down, down. So right, basically this, and then down and down this. So this is the one path. Second, it says down, 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 and then it says, this right. Or it can say follow down, 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 and this right, right. So this could be, for this given in a particular scenario, this could be the valid path for this one. So for this example, like if 3 and 2 were there, right, 3 comma 2. So this could have been valid path. Let's draw the diagram for this one, like 3 comma 2, which the explanation they are given. So 3 basically 1 2 3 and 2 basically 1. So this is one of the valid square rectangle. And for this, total number of ways should be like coming from here to here would be, one would be with this, second would be this, third would be down, right, down, right. Now let's say if I try to go right, down, I can't go back, right? So this would be invalid move. So that's why you can see, like, for this one, total number of ways would be 3. And for the first one, it's 28. We'll try to find that solution as well. So let's see what could be the ways, how it can be 28 ways. So before finding this 28 ways, like, can we try to find, let's say, if robot try to come from this position to this place, like, how many total ways it can take? So it can take only one way, right? Coming from here, it will have only one way. Similarly, if robot wants to go to this position, it can only take one way, like it would be the bottom. And similarly, robot wants to come here, it will have only one ways, which is bottom, right? Similarly, if you see from here to here, we'll have only one way. From here to here, we'll have only one. From here to here again, we'll have only one. From here to here, if you're coming again, we have only one way, right? And from here to here again, we'll have only one way. We can only come this way, right? We can't go this, this, and this. This is invalid move. So now, so we can see in the first row and first column, total number of ways will always be one to go from here to here or here to here. Now let's try to see if robot wants to come here. So what would be the total number of ways? So one way would be like right and down. Second could be down and right. The total number of ways would be only two. So here we have total number of ways as a two. Let's say if robot wants to come here, this place, right? What could be the ways? One would be right, down. Second would be down, right. Third would be right, down, right, third. So these are the total three valid moves, right? So here robot can come in three possible ways. If you see how this three is coming, it's basically sum of these two numbers. And this two is nothing but sum of these two numbers, one and one, this and this, right? Try to see here how many ways it will take. So let's assume will it be four? So we'll see. So here 1, 2, 3, 4. So here again it's coming as a 4, and this will go all at this way. So 4 and 1 is would be 5, 5 and 1 would be 6, 6 and 1 would be 7. Now let's try to fill the same like this as well. So here we'll have 3, here we'll have 6, here we'll have 10, here we'll have 15, here we'll have 21, and now here we can see here we got 28, right? So that's the way to do it. And can we solve it in using a program? So yes, definitely. If you see what we are doing, we're following the same thing. First we got all these numbers, and then basically it's kind of recursive solution of all the previous rows and previous column values. So let's say m is 3 and n 7, basically like m is basically starting from 1. If you see m is starting from 1, not exactly 0. So we can write if m equals to 1 or n equals to 1. If that's the case, then we can just return 1. Otherwise, just use recursion. So unique paths of what? So if how do I am coming, like for this one, how do I am coming, like solution would be like the previous uh, rows value, so which is m minus 1 into the same column plus, again call the same function with what? The in the previous column into the same rows. So to the previous column would be in the same rows. So rows is same and previous column is basically this one. And we can just return it. And now let's try to run it. Cool. So this works. And now, but since we're using recursion, like this won't work into the big use case. Let's say if m is 15 and 20, right? So this will give us a stack overflow error because stack, like recursion initially internally uses stack to store that, right? So in any of the interviews, try to avoid, let's say, as much as recursion we can do it. So what could be the better approach? Better approach for recursions to remove, like one thing could be like, so dynamic programming. DP is basically, what the DP say, like whatever the information previous solution which we already have done, are captured, right? We don't need to, just go and solve them. We can just store the previous solution and reuse into the future. So what do we mean by that? To come to this 28, we're just reusing the solution 21 and 7 because we knew this here. We have a solution of 21 in here 7. So can we just save, to them into somehow in some variable or something, and just provide the final solution. So to do that, since this is a grid, we can create a 2D array and then store all those values and just return the final data. So let's try to do that using dynamic programming. So for the very first thing, we need to create a 2D array first for that. So let's create a grid just to new array of m. Let's call it I equals to 0, I should be less than m, I plus plus, grid of I equals to new array n. So now we have already created a 2D array, and we know that we can save these values. And at the end of the day, we can just return m minus 1 and minus 1 from this grid, right? Let's just quickly go and save these values into the 2D grid. For let I equals to 0, it should be less than m I plus plus. For let j equals to 0, j should be less than m j plus plus. Now, what we are doing, let's first fill all the rows and column using 1. So can do if I equals to 0, if we are into the first row, then we can initialize grid of the first row and all columns in the so row is constant, and for each column 0 1 2 3 4, right, we can initialize using 1. And similarly, if you're into the first column, right, so if j equals to 0, then again we can initialize the grid of I for each row of the first column. We can initialize using 1. So this part and this part we have already done. Now the calculation is remaining for us. So if that's not the case, so if I not equals to 0 and j not equals to 0, if that's the case, like if I and j is not 0, then we know that we can find the solution of grid of I comma j from the previous rows number and previous column number, previous column. So grid of I minus 1 comma j plus grid of I comma j minus 1. So now we have already saved all the values here, and at the end of the day we just need to return the final value. Return grid of m minus 1 comma n minus 1. Let's try to run it. Yes, and we can submit the solution because now we are using a dynamic programming, so we're just going to use extra space, but this will work for all the test cases. So this has been accepted. And what would be the time complexity and space complexity? So space complexity would be big O of number of nodes, because we are going to save that many values, like number of elements into the grid. And similarly for this one, our time complexity would be again big O of number of elements into the grid on nodes.